These are the, just relative size of the pink. And the chum salmon when they come out, the sockeye when they're going by. These are Atlantic salmon and sea trout or brown trout in the European countries. Look at how much larger they are than sockeye and chum and pink salmon. And these fish are seriously impacted by sea lice in Europe. And so we had to bring forward evidence of that to debunk arguments from DFO and the farmers and the province that sockeye were not impacted by sea lice. So these recent reviews, we put forward some papers by Mark Costello again, saying that it only takes 5 to 10 lice per fish of Atlantic salmon to kill that fish. So again, we have to bring this European evidence over because our own regulators are not providing it. I did mention pollution. There's a really good paper done by Dane Finstad, a Norwegian researcher. And what he did is he looked at juvenile Atlantic salmon that swam down Norwegian rivers, and the very polluted rivers, now this isn't germane to the Fraser, but the ones that are swim through polluted waters, their immune systems are compromised, and once they get out by a salmon farm, they're far more likely to die from lice than a fish that doesn't swim through polluted water. We don't know if this is happening in British Columbia. We just presented the evidence at Cohen. We don't know if it's happening. But we did hear the director of water quality for Metro Vancouver saying that they really can't control their pollution in the Fraser, and it's a big problem. So there may be some sublethal impacts on these fish after they're swimming through polluted waters as well. So we put this evidence forward, and there was a couple of days of testimony on this. So I'll finish up with salmon farm here fairly soon in terms of lice. But just before Christmas last year, the provincial veterinarian, Dr. Gary Marty, who's definitely a salmon farm supporter, worked with Sonia Saxida, who's a veterinarian who worked for Marine Harvest for a long time. She's got a private company now, and a fisheries scientist in Alaska. Examined all the sea lice data and the productivity of fish around these farms, and they found that the productivity of salmon, which we talked about earlier, is not associated with salmon farming. That was their big finding. It was a huge paper. The salmon farmers were on the top of the hills trumpeting this paper. And so the salmon farmers brought this paper forward. But the day that the aquaculture hearing started, a rebuttal to this paper came out. So what they were saying is that you don't need to separate farming and wild salmon. We're all just making too much noise about this. The day that the hearing started, Marty Kokozik, Brendan Connors, a postdoc at Simon Fraser, Alex Morton, Mark Lewis, Larry Dill at SFU, and Ray Hilborn re-examined those data that were published and trumpeted, and they found that they didn't do the proper examination of the data. They didn't put the proper spatial and temporal controls in examining data. So they found that just the opposite of what the provincial veterinarian found is that sea lice abundance of farms is negatively associated with productivity, and the results reconcile contradictory findings of previous studies. And management policy measures designed to protect wild salmon and sea lice should yield conservation benefits. So it's just so sweet to have this paper come out the first day of the aquaculture hearings. A lot of writing on here. Don't worry about it too much. That's Larry Dill. We twisted his arm big time. He has quite a few grad students working on salmon farm impacts. He did one of the reports on aquaculture. But the salmon farmers chose their own scientist, who again was a former DFO scientist, to do his own report. In his report, Dr. Don Noakes suggested there is no problems. Larry Dill's report suggested that there are all kinds of problems. That's technical report 5D, impacts of salmon farms and Fraser sockeye. And so he even went further. He said the most obvious solution to the risk of pathogen infection is closed containment aquaculture. Now you can still have aquaculture, but just don't put these farms where juveniles have to pass by these farms and pick up lice and pathogens. One of the other things that Larry pointed out in his paper is lice are vectors for disease. This is really important with all the disease stuff that's being found. They can transmit infectious salmon anemia. They can transmit IHN. They can transmit other diseases on their skins or in their guts. And when they go out and bite another fish after coming from a farm, they can transmit these pathogens. And these are the evidence that we've seen. This is ISA transmission. Larry Hamels at the University of PEI, he found that lice are vectors of ISA. So this was an eye-opener for a lot of people as well. So it may not be the lice themselves that are having impacts on Fraser sockeye, but it may be the diseases that they're transmitting. And there's two species of lice, Leptopterus salmonis and the caligus, which is also called the herring louse, much smaller, far more mobile. These lice are jumping all over the place. and the caligus may be the biggest problem in terms of transmitting these diseases. So this is Brendan Connors, this is Marty Kozik, both really excellent louse researchers in the Broughton. Marty's now at the University of Otago in New Zealand. He works in BC still. And Brendan just did an excellent PhD on salmon farming impacts. So Brendan took all the data of the sockeye productivity, and he looked at the sea lice numbers, he looked at the farm production, and what he found was that he couldn't find just one thing, okay, that was affecting these salmon. He found that there were 3 things that were correlated with declining sockeye productivity, and that may be something that's totally expected. You know, you've heard of the death of 1,000 cuts, but it may be similar things are affecting sockeye, not just one thing, but there may be several factors that are causing these declines. He found that the total number of farm salmon along the route of the sockeye migration was correlated with sockeye declines. He also found that the number of pink salmon in the ocean, especially the winter before the juveniles got out, was correlated with declines. And there are several papers that show pink salmon are substantial competitors for the krill, the food that both sockeye and pink salmon eat, and they're increasing in numbers, you know, in the North Pacific, and that may be having, and apparently in his analysis, having a negative impact on fraser sockeye. And sea surface temperature, which is related to food productivity, was also negatively correlated to sockeye productivity. So there were 3 things that were acting in concert in this analysis. This paper is coming out in biological letters in the next couple of weeks. And so, you know, it gives us more of a hint that there may be something over salmon farming, but he didn't have this fine enough spatial detail to actually look and see if the lice were impacting, you know, if that was the cause or not. So we did testify on some of the papers that we've been working on this coast. We did a research on sockeye. We found 35 stocks of sockeye, juvenile sockeye around salmon farms through DNA analysis, and we found that once they passed the farm, they picked up a lot of sea lice from those farms. And compared to Alaska, where there's no farms, our sockeye in the Strait of Georgia had 10 times as many lice as the juvenile sockeye in Alaska, where there's no farms. So we presented this data. We don't have impact information. We do know that sea lice are amplified when sockeye pass these farms in the Strait of Georgia. Okay. So we were presenting all this information. We also looked at use of chemical controls on farms and how they control lice. We testified about that as well. So to sum it up, a lot of the testimony we heard was that there were population level impacts of lice. We've shown in many studies there are behavioral and disease impacts. Lice don't just kill by sucking their ectoparasites, by sucking the fluids out of these juvenile fish, although that's one of the main problems. But they cause these fish to do all kinds of weird things. You get lice on these fish, they start doing this. You know, they're flashing, they're jumping. And these guys that are researching them find that they're far more easily seen by birds that pick them off and things like that. And they did experiments too, Brendan Connors in their lab. If they infected a school of juvenile pink salmon, the ones that had lice on them would always be at the back of the school, or they'd be at the outside of the school, where they're far more easily killed. They also put in a cutthroat trout into these little pools, and they let them eat as many pinks as they could, and then they separated them out, and a fish that had a louse on it was 3 times more likely to be eaten by a cutthroat or a coho salmon than one that didn't have a louse on it. So all these things add up to impacts from lice, and this is all testimony that we heard at the we know farms amplify the loads of lice on juvenile fraser sockeye. We showed that. We know that the treatment triggers that they use for controlling lice are totally arbitrary. They've never been tested on whether they're effective or not. And area-based management, where you try to control lice on a coordinated basis, will reduce lice. We've got a paper coming out on that too, but it's no panacea. And the chemicals that they use, lice are so good at developing resistance to these chemicals. They've done it all over the world very quickly. They're just marvelous at developing resistance to any chemical controls that you throw at them. So we're going to see a failure of the current methods here in Greece and BC before too long. In terms of promoting uncertainty, this is again, remember these scams. Paul Sprout, Regional Director General, wrote to Globe and Mail, sea lice and fish farms are not the explanation for this year's extremely poor rates of wildlife sockeye. Well, what does he base that on? Well, he bases it on wishes, I think, more than anything. And they also say that the sea lice species found in juvenile sockeye are not the same species that typically infects farm salmon. Bullshit. Excuse my language. You can look at the farm data. You can look at what's on the juvenile fish. It's the same species. So how can the regional director general say this in a letter to the editor, and with a straight face? He did.
He gets paid too.
Yep. So when this was all done, all the groups made recommendations. They said what they thought were the problems, and they said what they thought weren't the problems. So the BC salmon farmers, I just had to extract a couple things. They said, well, sticklebacks are important alternate life hosts. Well, they don't know that. Sticklebacks do get lice on them, but they're trying to point to them as a more important source of lice than salmon farms, and that's just not credible. There's never been a case, and there's been many studies where lice have completed their life cycles on these marine sticklebacks that have armored skin, and the lice just can't get enough nutrients to reproduce. Fraser sockeye are relatively resistant to lice based on that threshold work, and that was totally debunked in the Cohen inquiry, but they still went with this recommendation of Cohen, and hopefully they'll see right through this. And based on the provincial veterinarian's report, sea lice are not a significant threat to salmon as one thought. They didn't even mention the rebuttal, which was tabled as evidence in the Cohen inquiry when they made these recommendations. So, unbelievable. Now, I'm just going to finish off a little bit with the virus issue, and then I'll shut up. Viruses started surfacing as a big issue, especially when Alice Morgan started digging through these 500,000 documents there. She started seeing evidence of viruses in research that's been going on in some of the salmon farm records. And she published a year ago now, in January, a paper which shows that you could actually see the genes turn on and off, mortality genes of these fish, these sockeyes that came back towards the coast. And she could predict, based on the genetic pattern of returning sockeye, how many are going to die. And, but she wasn't allowed to talk to the public about this. She published this in Science, in one of the most prestigious journals in the world, but she was Muslim. She was not allowed to talk to the public about this. She originally began investigating the early return phenomenon, which they saw in 1996. You probably all know that sockeye started returning early, sitting in the lower Fraser, and suffering the impacts of warmer temperatures and parasites and things like that. And that's really important with this temperature paper. But what she discovered was that there was a mortality-related signature in a significant portion of the sockeye. She could actually see this signature in the genes. And the sockeye with the signature had 13.5 times lower probability of making it to the spawning grounds, and up to 95% of those sockeye that showed that mortality-related signature died. And she thinks it was related to an unidentified parvovirus in these fish. And that's where the whole story started getting really interesting in the whole disease hearings. We looked at the salmon farm records. We've had to fight with the province to get their audited records of the salmon farms. They weren't going to give them to us, but we had to fight with them and got those, and really embarrassed them. But we started seeing these evidence of bacterial and viral infections on all kinds of farm salmon records. And this has never come out before, so this was really quite instructive to see these kind of evidence. Now, we had a PFO pathologist there, and there's a big debate. If we detected ISA in British Columbia, this is before it was detected, I would presume it came from break in biosecurity, either at a farm level or through international transport. The main way that this virus got into Chile when it came to this outbreak was from salmon eggs that came from a hatchery in Norway. Okay, and we still import salmon eggs from overseas, and that's the way that you do transport viruses in there. So she was saying it's going to come from this. One of the other pathologists there, Dr. Kent from the University of Oregon, said, no, it'll come from wild fish. And she said, oh no, I don't agree. I don't agree. It's going to come from the farms. There's also evidence in several papers that were presented that ISA and these viruses can mutate into more lethal forms on these farms because of the tight conditions, like a big chicken farm, right? You know, avian flu, all those kind of things happening when you crowd all these animals together. So very interesting testimony from the DFO pathologist. And then the bombshell. The hearings were closed, but Rick Rutledge, an SFU prof who worked with Alex, was working at Rivers Inlet, and he took some juvenile fish that looked terrible. They were really emaciated and everything. He sent them to an internationally accredited lab for testing ISA. And he got back out of 49 incidents, 7 had ISA-like virus. And he had a press conference. And you know what just hit the fan. It was unbelievable. And the denial that started right away from everyone there and in government. But he had the evidence, and the labs were accredited, and it was there. So then we reconvened in the Lost Dialogue Center, and we put these exhibits here. But the other thing that came out is we found out after these testimony was over in September, and after Dr. Rutledge